In this video, we'll be continuing with Chapter 5. This is Chapter 5, Section 3, Equivalent Ratios and Rates. What you'll learn in this video is to use equivalent ratios and rates to solve real-world and mathematical problems. And remember, a ratio is comparing two numbers by division. Your term for this video is equivalent ratios. It is the only term. Be sure that you pause the video when you see it to write down its meaning. Two ratios that name the same number are equivalent ratios. You can use a multiplication table to find equivalent ratios. Using a multiplication table to solve equivalent ratios, you'll see on the screen a multiplication table. If you don't remember these, it's just the number across the top and the numbers going down the side. Wherever their boxes intersect is the multiple of those numbers. So let's say red and blue paint are mixed in a ratio of 3 to 5. Use a multiplication table to find four ratios equivalent to 3 to 5. So to make a table of equivalent ratios, we're going to use the rows for 3 and 5 in the multiplication table. So that's the row for 3 and the row for 5. So if we do that, we're just taking the numbers and transferring them into their own individual table. So we have our original 3 to 5. Then the very next numbers, 6 and 10, 9 and 15, 12 and 20, 15 and 25, and 18 and 30. We're just working our way straight down the multiplication chart, getting a row of equivalent ratios. So the equivalent ratios are 6 to 10, 9 to 15, 12 to 20, 15 to 25, and 18 to 30. Pause the video and do these two in your notebook. Be sure to write down the original question and show all your work. Another way to find equivalent ratios is to multiply or divide each term of a ratio by the same non-zero number. So that just means if you're going to multiply, we would do 6 times 3 to get to 18 and 8 times 3 to get to 24. Or you could do it by division and just divide by the same number. So 6 divided by 2 gets us 3. 8 divided by 2 gets us 4. So just the same way when we were doing equivalent fractions, whatever you do to one number, you have to do to the other one for them to stay equivalent. You can use this process to make tables, coordinate graphs, number lines, and diagrams to help you solve problems with equivalent ratios. Let's look at a sample for solving rate problems. Todd earns $7 for each hour he works. So his rate is $7 per hour. How much will he earn for 6 hours? So first we're going to make a table of equivalent ratios. So if we know that 1 hour gets him $7, then we can do math. 2 hours, 2 times 7 gets me 14. 3 hours, 3 times 7 gets me 21. 4 hours, 4 times 7 gets me 28. 5 hours, 5 times 7 gets me 35. 6 hours, 6 times 7 gets me 42. So Todd will earn $42 in 6 hours. You could also do a double number line. So that's just taking the same information and writing it down on a number line instead. So we have 1 hour, 1 times 7, we know that $7 an hour, so 1 hour gets him $7. 2 hours gets him 14, 3 hours, 21, and so on, much like the table. The third way to do it is to plot it on a graph. So if we have plot equivalent ratios on a coordinate graph, use one term as the x ratio and the other term as the y ratio. It doesn't really matter which one you choose, but it tends to be easier If whichever one starts with 1 or 2, something small, make that your bottom number, and then whichever the other side is usually bigger numbers or stranger numbers, make those be the ones going up. So we have the same numbers, 1 and 7, 2 and 14, 3 and 21, 4 and 28, and so on. It's just 3 different ways to make a chart of the same information. Pause the video and do these 2 in your notebook. Again, be sure to write down as much of the original question as you can and then show all your work as to how you figured it out. Don't just write down an answer, show me how you figured it out. Now, some ratio problems can be solved using a tape diagram. A tape diagram is kind of similar to an equivalent ratio chart, but it's breaking it down so you can visualize the ratio. So if we have a ratio of round tables to square tables at a party is 6 to 1. The total number of tables is 35. So how many round tables are there? So our ratio is round to square. So round is our 6, square is our 1, because round is what they said first, so that's the first number. So we're going to draw a tape diagram. So we know there are 6 round tables, so 1, 2, 3, 4, 5, 6, and 1 square table, so 1. That gets us our total, so that tells us that there are 7 tables total. Or 7 parts, I'm sorry, because with the 6 and the 1, that gives us 7 parts. And the total number of tables is 35. So that lets us know that there are 30 round tables, because 6 times 5, because if we have 35 total tables, to split that into 7 pieces leaves us with 5 in each box. And then 5 times 6 gets us to 30. To think it out, say 7 parts of 35 tables. 1 part of 35 tables is going to be, so 35 tables divided by 7 to get it down to 1 would be 5 tables. So 6 parts, 6 times 5 equals our 30 tables. Pause the video and do these 2 in your notebook. Check your understanding. Pause the video and do the check your understanding in your notebook. Be sure to label it as check your understanding, number all your questions, and show all your work. Enjoy the rest of your evening, and I'll see you tomorrow.